Alright, here's going to be a quick lesson to look at an angle measured in radians, but without pi in it. Whenever you have pi in your radian measure, it's quote-unquote nice, because it's some fraction, some nice fraction potentially, of a full revolution, 2 pi. When you don't have pi in it, it ain't nice at all. I mean, in a certain respect, it's okay, because you're like, oh, cool, 5 radiuses. But when I start marching out 5 radiuses around the edge of this circle, I can only get so far confidently. Because I'm like, it's about 1, maybe 2, 3, I don't know, 4. But I just, it doesn't feel like I'm very well, anyway, able to accurately go that far an integer number of times. There's no reasoning, I'm just estimating, and so it's tough to do that. So instead, as a way beyond just sort of estimating where 5 lands you, so that you can start talking about the reference angle and what quadrant you lie in, what you can do is take the places that you do know. You say, all right, that's pi. That's pi over 2. That's 3 pi over 2. For example, this is 2 pi. And start getting decimal approximations. So we know that pi is about 3.14, and so half of a pi, half of 3 is 1.5, half of 0.14 is 0.7, 0.14 is 0.07, 14 hundredths, half of that is 7 hundredths, and so add those together, we're at 1.57. This is maybe more work than I need to do. I don't need this much accuracy, but I start to get a sense. Add these together. I've got 2 pi halves plus another pi halves is 3 pi halves. Add these up, and I've got 1 carry the 1, 7, 4.71, and finally 2 pi is about 6.28. That's great. If this one's about 4.7. And this one's about 6.28. 5's got to be about there. So beautiful. So now I have a sense of, all right, 5 is in the 4th quadrant. Cool. But now what's this reference angle? If I go ahead and drop this down, make a perpendicular, and whoops, let me try that again so I can go a little bit more straight. Wow, it's hard to do this with a stylus. I'm going to try one more time and maybe come from the bottom. Alright, good enough, whatever. So this reference angle is this guy. And, a little bit, well, how am I going to get that reference angle out of 5? It's not even part of the 5, right? But what you can do is see, well, wait a minute, if I go all the way around, that's 2 pi. And I'm running out of space here, but I'm going to I'm going to go ahead and erase some of this stuff. So I don't need this anymore. Bye, 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 bye. Bye, 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 bye. So all the way around is 2 pi. And that full revolution, I can see as the 5, here's 5 gets me to there. That's the angle I started with. That's 5 plus this little orange bit that I'm calling the reference angle. Total those together and you get 1 revolution around. So okay, so that's what I'm calling the reference angle, theta bar. But that looks like a variable. This looks like a constant. This looks like a constant. That looks like a variable. Solve this equation by just subtracting 5. And, let's make that look a little bit better. 2 pi equals 5 plus theta bar. Take away 5 from both sides, and I've got 2 pi take away 5 is the reference angle. About how much is that? About 1.28. How much is it exactly? Take out your calculator. How much is it more accurately, but approximately? Take out your calculator. What is it exactly? That's what it is exactly, 2 pi minus 5, and that's what my Open Math wants. All right, hope that was helpful. See you tomorrow.